All right, we are live. Welcome everyone to SQL Friday number 61. Today we have Kathi Kellenberger, who is going to talk about T-SQL window functions, which is, to me, the most important addition to the T-SQL language in the last 10 years. So I'm really happy to have you here, Kathi.
Thank you.
As soon as you're ready, you can just start sharing. I think at least you're allowed to.
Okay. Screen. All right, can you see the screen?
I see the screen, yes.
All right. Welcome everybody to my session, Introduction to T-SQL Window Functions. I'm Kathi Kellenberger from Redgate Software, and this topic is near and dear to my heart. I've been speaking on window functions for 9 years now, since SQL Server 2012 came out. I'm going to tell you, before I get started, I want to remind you that Past Data Community Summit is coming up in just a little over, actually exactly a month, and it's a free online conference. Redgate is hosting this. It is free except for pre-cons. There are a number of wonderful pre-cons I should bring up as well that are just $200, that's US, for each pre-con, which is about half the price of what they used to be at the in-person Past Summit. So I encourage you all to sign up and look forward to seeing you there. So now before I get started, I want to tell you a little story. I was working for a customer. This is probably about 7 or 8 years ago. And I was an ETL developer at this organization, at this customer. And the DBA came to me and said, Kathi, I am pulling data from the stock market every night. I have a process to import that into SQL Server, and I'm trying to do some calculations to figure out the closing price from one day for a stock to the closing price to the next. What's the difference between those 2 days? So I helped him write that query. A few months later, I was talking with a consultant, a junior consultant at the company that I worked for. And he said, Kathi, I'm pulling some data from the stock market, and I have an ETL process that I'm using to pull that data into SQL Server, and I've written a query to compare one day to the next, but it performs terribly. Can you help me with that query? And I wish I had a copy of that query, because it was just it was crazy. It was like 7 layers of nesting subqueries to get, it was giving him the answer, but it just was very difficult for him to write, as well as difficult for SQL Server to run it. So in both cases, I gave them the same solution, and I'm going to tell you about that when I go over here to a demo. Hopefully you can see the demo. And I've got some made up data in the stock history table. So basically there are made up symbols and made up prices. The dates are real dates, but I have a total of, and I gotta move this little thing out of the way here. There's a lot of rows here, almost 700,000 rows in this data, okay? And it's all made up. And here's the solution, which is not very difficult to write. I'm sure it doesn't make sense to a lot of you at this point, and don't worry, by the end of this session, you'll understand what I'm doing here. But if I run it, it takes a while to populate the screen with this many rows, but it only took 6 seconds to run. If I had been saving that data to a temp table or whatever, it would have run even faster. So I have the close price from one day it's pulled forward to the next row, and then I can do the calculation. So this is the query that I gave to those two gentlemen to help them solve what they were trying to do. And it ran fast, it was easy to write. So that's what I'm going to be talking about today. Queries like this with this over clause in it. And they're called windowing functions, or you'll hear me say window, windowing, windowed. Those are all meaning the same in this context. All right, so let me go back to the slides. Okay, so what in the world are these things? What are these window functions? When I first started talking about window functions, a lot of people assumed I was talking about something with the Windows operating system, but that's not what they are at all. These are actually T-SQL functions. They're based on standards, so you'll see window functions in Oracle and other SQL-based database platforms. So what's happening is that a window is defined for every row in the results, and a calculation is performed on that window. Okay. Window functions can only be used in the select and order by, which doesn't sound bad, but then when you try to put them in the where clause, especially, you run into some issues. So you have to separate the logic out. And I do have some examples of doing that in the demos. Window functions will always have an over clause. I did run into one exception on that, something with string aggregate that I had kind of forgotten about, and then I saw there was an example in the slides with that, and I really didn't look into that to see if that's truly a window function. So I'd have to go back and take a look at that. But there is another situations where you'll use over clause, and that's the next value for function uses an over clause as well, and that's with the sequence object. I'm not going to be talking about the sequence object today. I'm only going to be talking about window functions. So usually when you see an over clause, that means a window function. And what I've noticed, especially when I first began speaking about window functions, is that a lot of people were using some of them and didn't really know what they were called. And in fact, I didn't either, because they've been around, some of them have been around since 2005, like row number. And I was using row number. I didn't really realize it was a special group of functions until 2012, when Microsoft introduced several others. And I feel like 2012 is, that just was a really, really important release for SQL Server because all of this new functionality was added. So let's talk a little bit more about the over clause. There's three possible things that can go in there. I'm going to talk about two of them first and we'll save one for a little bit later. Some of the functions that I'll talk about require an order by inside that over clause. Not all of them. Some of them require that. And that's so that the lines, the rows are lined up the way we want to do the calculations. And that's important for some of them. So for certain functions, we're going to have an order by there. It is not the same order by as the one that you might have at the end of your query. And that can be different. They might be the same, but they can definitely be different. They're different. SQL Server is going to have to do a little bit more work than you might expect, because it's going to have a couple sorts instead of maybe one sort. And there's also this optional item called partition by. So for example, in the previous example I showed you had an order by because we needed to line up the rows by the trade date so that SQL Server knew which day was the day before. So we had an order by to line those up. And then we also had a partition by because I don't want to compare one ticker symbol to a different ticker symbol. So partition by kind of divides that window up. The way I think about it is that imagine you have a window in your home, and so the whole thing's a window, but you might have smaller sections called window panes, and each one of those smaller window panes is also a window. And in this case, it's what we're working with, a partition. Okay, so we think about that physical window. We've got panes, but in our window function, we have partitions. Okay, so our window is how we let the function know which rows to operate on, which set of rows to operate on. And under the covers, SQL Server will actually create some temporary work structures to help it do that. In some cases, the performance is really good. Some cases, not so good. I have a whole session that I talk for an hour about the performance of these, but this particular session, I'm just going to do an introduction to them. Once in a while, I'll mention performance, but this session is not dedicated to that. So if we start with some data that looks like this, I have an order ID, I have a customer ID, order date, and a total amount. And I want to use an over clause that looks like this, order by total amount. So what SQL Server will do under the covers is order that data like this. And here's my window. My window looks like this, and it's ordered a certain way. Now, I may not want my results to be ordered that way, but when I'm working with this window function, that's what I want. I want it lined up like this for whatever reason. And I might also have a partition by. So in this case, I'm partitioning by customer ID. I don't want the calculations from one customer to overlap the other one. So here I've got it separated out by customer ID and then ordered by the total amount. So in this case, for customer 102, here's my window or my partition that I'm looking at. For the next customer, it's just this one row and so on. So I have this window that I always think of it as looking through the window. I look through the window and I see the rows that I'm going to be operating on. So the first group of functions that came out in 2005 are the ranking functions. And the first one, and a lot of folks have used row number. Row number just adds a unique set of numbers, and they're going to be, there's an order by for all of these ranking functions. You've got to have an order by to let SQL Server know how you want the numbers applied. So the interesting thing about the ranking functions is they're typically not the answer to the problem. It's typically a step along the way to solve something else. And they're very, very useful. So there's row number, which provides a unique number over the partition. Okay, the partition might be the entire window, might be small sections, but a unique number. Rank works very similarly, but if there's any ties in the data, so if I take that order by, and that order by is not a unique column or combination of columns, there could be some ties in the data. So it takes care of that. There's also dense rank, very similar, works a little bit differently. And there's this thing called entile. Entile is kind of different because what it'll do is group the data by buckets. So if I look at that same data that I looked at before, and I just say, I want row number over order by total amount is going to take that entire set of data, entire set of results, and add this row number in order of total amount. Now, again, I might have a different order by in my query. And if I do that, well, then it won't come back in this, the results will come back in whatever order I had my order by. If I add a partition to that, then notice that the row numbers are going to start over. Here I've got this first customer 102. The row number will start over when I get to customer 103. And it'll start over when I get to customer 202. Okay, so that's how row number works. That's how the how rank and dense rank work as well, unless inside one of these partitions here, there would be a tie. So in this case, total amount is not a unique column. It'd be very unlikely that it would be unique. So in that case, there could be a tie or the same value for different rows. And in that case, rank and dense rank would show slightly different results here. So let's take a look at how this works. I'm going to use AdventureWorks for a lot of the demos today, just because it's a lot of people can grab it easy enough, and it has data that a lot of folks are familiar with. So here I've got a query where I'm using row number. Again, most of the time row number is a step along the way to the solution. It's typically not what I'm trying to accomplish. So I have partitioned it by customer. So if I look at, here's the first customer, in this data, like a lot of the customers at the beginning of the customer ID values all have 3 orders. So I don't know why, but they do. Later in the data, it doesn't stay like that. Also ordered by order date. Again, that is not unique. And in AdventureWorks, they don't record the time here, so it's possible to get some duplicates. All right, so we see this first customer, 123. We see the next customer, 123. Here's a query where I have used row number, rank, and dense rank. And I chose a specific customer, and I chose that customer for a reason, because I'm ordering by order date. If I look, here it is. There might be more, but here's one. Here's one where they have 2 orders the same day. So if I look at row number doesn't care. All it cares about is the position of the row. Okay, so it says, I don't care that these are the same, 13, 14, 15. Okay, if I'm using rank, let's see, is that the same? Why am I not seeing what I expect? Oh, I'm looking at the wrong thing, I guess. 315. Okay, now it looks a little better. Okay, if I look at rank, I see 13, 14, 14, 16. So, oh, I see. Well, I grabbed the wrong 2 rows. And that's what was throwing me. I grabbed that 5, and these are the 2 I should be looking at, 13, 14, 15, 16. Okay, do the right thing. Results will look better. When I look at rank, I see 14, 14 here. Basically, rank is saying these 2 are ranked the same. All right, I see the same thing on dense rank. These 2 are ranked the same. But then once I get past that tie, then it's a little bit different. I used to think that dense rank didn't waste numbers because it continues on with 15. However, rank kind of catches up with row number. So eventually I figured out, and I think I have a note here, row number cares about the position. That's all it cares about. Dense rank is logical. It cares about the unique value. So dense rank is saying this is the 14th unique value. So is this one. But this one is the 15th unique value. Rank is kind of in between. It cares about the position, but if there's a tie, then it's going to rank them the same. But it cares, when it gets here, it says, hey, this one's in the 16th position. And it's, for me, it's really hard to know which one of these three is going to be correct to use. If for some reason your order by here is not unique, you may have to choose one of these. Typically what I do is I start with row number. If I don't get the results I'm looking for, I'll try one of the other two to see. And I think I do have some bonus material, if I have time, I can get to kind of show a couple situations where dense rank would make sense. Typically, you're going to want your order by here to be something unique. Then you're not going to have to worry. You'll get the same results with all of them. And you can use a comma delimited list here. It can be comma delimited, so you could have more than one item there. And let me show you Entile. I didn't show you Entile yet. Entile is a little bit different because you have to specify a value here about how many buckets you need. And I'm going to just comment out this part here first. So I have some sales people that I'm in charge of, and I want to give them all a bonus for how well they did with their sales. So I've got Entile. I'm going to order by the sum of total due for a particular time period. And so what ends up happening is my high achievers end up in bucket 4. My lowest achievers end up in bucket 1. And notice that my number of rows is not divisible by 4. So I've got an extra value here and an extra value here, and then we've got 3. So if you can't divide it, if you can't divide it evenly, you'll get those extra rows at the beginning. So then if I just go ahead and take that and multiply it, in this case by 1,000, then I've got my bonus amount that I'm going to give to my salespeople. Another thing to note here is that you can use these in any calculations, things like that. Really the restrictions, there's a couple of restrictions, but the main ones is that you cannot use it in the where clause, group by, from, because those operations have to complete earlier than the window function operates. Okay, the window function is going to operate on the set of rows that have already been filtered and grouped. And if there's a having, that as well. So that's all going to take place first. Here's one more. In this case, what I would like to find is the first orders placed each year. I could also do something like the 4 most expensive or whatever. So the first thing I might think of is like, hey, I could use row number here and just partition by year and just filter on that. I want 4 orders, so I'll do less than 5. Unfortunately, that is not going to work. And to be honest, this is the first time I ever heard the term windowed or at all, is when I was trying to do something like this. This is back a long time ago, but I'm like, what do they mean windowed functions? I had not heard of that. So that was the first time I heard the term when I tried to do something like this back, 10 or 12 years ago. So one thing you can do is separate the logic. I often use a common table expression. You could use a subquery. You could use a temp table or a temp variable, whatever your favorite method is. So in this case, what I do is I just went ahead and figured out my row number here. There's my row number. And then in the outer query, I'm going to filter. Okay, and then that works. So there's my first 4 for that year, and so on. So this is one way to do it. As I mentioned, that there's others, but if you need to filter on it, you're going to have to separate that logic out in some way. So I'm going to ask at this point if there are any questions.
And now I've managed to unmute myself. There are no questions in the chat. Sorry.
Okay, sounds good. I'm going to keep going then. And there we go. All right, the other type of window function that was introduced in 2005 are the window aggregates. So these are typically your favorite aggregates like sum, average, min, max. I think most of the time it's going to be sum or average, but you could use the others. And the cool thing about this is that you can add these with no group by. By adding the over clause, we don't have to add a group by, which is nice if you want to include a bunch of detail and you want to have the window, or you want to have an aggregate, but you don't want to group on all of these detail rows. You do not put an order by in this case. And if you think about it, imagine that I have 10 numbers that I want to add up. They don't have to be in any certain order for me to add those up. So you don't need an order by. You can use an order by on something I'm going to talk about later that will give you a different answer. And of course, partition is always allowed. Partition is always optional, depending on what you're trying to accomplish. So here's some data similar to what we looked at before. If I just add sum total amount, and I'm going to call this the empty over clause, just an empty over clause, I'm going to get a grand total over that entire set of rows. If I do the same thing, but partition by, in this case, customer ID, now I'm going to get a subtotal on that customer ID. And I think I got it now. Yeah, so there's row customer ID 102. And these rows are not ordered. So I think that's all of them. So for that particular customer, that's the subtotal for that customer. And notice that the other customers are showing a different amount, but for the grand total, we're seeing that same amount overall. So you might want to do some kind of a calculation here, like what percentage is the subtotal of the grand total, something like that. All right, so let's pop back over to demo again. If you think of questions, be sure to put them in the chat, and I'll get to them after each demo. So let's say I have this data here. I have this product listing, and each product has a list price. Okay, so this data is really old. A nice bicycle is going to cost you a lot more than that nowadays. Probably going to be spending a few $1,000s for a really nice bike. Well, there's one that's $3,000. But anyway, so that we've got a product ID, a name, a list price. I've got this finished good flags because there are some parts that they don't necessarily sell, and I don't care about that in this particular scenario. So let's say I would like to get an overall count and an average list price. If I just add count and average, it's not going to work. I mean, this is the error I see more often than any other error when I'm writing T-SQL, because I forget to put a group by, or I forget to add a new column that I just added to the query. So it's not going to work because it wants to have product name and list price in a group by. But if I add that, I'm going to go ahead and add that. Now my query will run, but I'm not getting the results I want. I want an overall count. I want an overall average list price, but it's just giving me the same value for each row because I'm grouping on all three of these columns. It's not what I want. If I would add an over clause here, so previously I just added count and average, but if I add count over, average over, now I'm getting what I want. I have an overall count, 295. I have an average list price of 744. So I could use these now in some kind of calculation, or maybe on my report I want it in a certain spot. But you know, now I've got that to work with. Another thing that we can do is we can use these to provide summary type on a different aggregation level than our original query. So here, it's a little tricky, and sometimes it makes more sense to separate the logic out because it's just counterintuitive. Here I've got a list of the years and the sales, okay? So I've got group by year. If I can add, if I try to add, this is already an aggregate query, so I'm going to try to add sum over. But when I do, I get this total due is invalid in the select list because it's not in an aggregate. So when I first got this error, you know, 10 or 12 years ago, I was really confused. Why am I getting this error? Because total due is in an aggregate. And I look at this and say total due isn't an aggregate. However, when I'm using it like this, it's not a real aggregate that goes with group by. It, to me, it's like so hard to really explain, but all of the grouping happens before this. So this is not part of the aggregation. What you have to do is apply the window function to the aggregate expression. So you end up with this sum. And that just does not look right because you cannot nest aggregates in SQL Server. You can't nest aggregates, but that's not what we're doing here. We are including, this is a window function. This overall thing is a window function. We are applying it to an aggregate. So here I'm getting the overall sales here, okay, like I was expecting. Here I've got the yearly sales, here I've got the overall. And now I can do my calculation if I like. I'm using this format function here. Don't use that unless you are working on just a small number of rows. So I'm just using it on 4 rows, so it's okay. This guy also introduced in 2012. Typically not great performance, but in a situation like this is fine. So now I'm getting my percent of sales here. So even in my query, I may not even want to display this part because this is the answer I'm going for. So it's a little bit counterintuitive, but we're basically applying the window function to an aggregate. So this part of it is part of the aggregation that happens up front, and the window function happens later. So I have this data that is already aggregated, and now the window function is applied to that. Here's another way to do it that might be easier for you to understand. If I go ahead and aggregate like this first, okay, and then apply the window function to this column that comes back from the common table expression, I'm still doing a window function on a sum, but it's easier, I think, to understand. Doing the aggregation up front, apply the window function to the results of that. And that is easier to understand, I think. It's doing the same thing. So are there any questions at this point?
No questions in the chat. And don't be shy, people. If you have questions, just ask them. Now is the time.
Yep. So everything I've talked about so far has been 2005. And in 2012, I feel like SQL Server became a superhero, superpowers. And for years, I was presenting this 2012, 13, 14, 15, 16, on, and not many folks were on 2012. And I would get, usually every time I presented this, which was pretty frequently, someone would come up and say, now I can go to my manager and tell them why we need to upgrade. So at this point, hopefully majority are on 2012. Even 2012, I don't believe has full support anymore. It might have security patches, and that's it. I'm not even sure about that. I know that, it's now 11 years later, so we should have moved on from this version. But I know there's folks out there that are still running 2000 and 2000, and probably even some SQL Server 7s out there in the world. But I feel sorry for them. But that's a possibility. So in 2012, we have these wonderful enhancements, not only for window functions, but a lot of other new T-SQL features. Microsoft really has not made this many, many new enhancements since then. However, I would say since 2012, the most important things they've done are the intelligent query processing features. That I have a whole nother session on that as well, which maybe I could talk about next time this comes around. So
sounds like a good plan, I think.
Yeah, there we go. Another fun
thing. Can I give you a
about.
question from the chat, which came in?
Sure.
Which one of doing the sum of the column name compared to wrapping the grouping in a CTE, which one performs better? Is there any difference between them? It's a question from Vilius.
Yeah, I think in most cases, it's probably going to depend on how complex the query is to really take a look at that. In this case, it's identical. Obviously, as the query gets more complicated, it's going to be one of those it depends. But when you're working with window aggregates, you want to always pre-aggregate in some way if you can. You will get a performance hit on window aggregates, and again, I don't really talk a lot about performance in this session. We could have that session too, not just on window function performance. You are better off pre-aggregating in whatever way you can. In this case, that does happen both ways. So, but yeah, it's going to depend. As long as the pre-aggregation happens and that window function in that particular case only applies on a small number of rows, the performance should be good either way. So,
thank you.
All right, so great question. So accumulating aggregates. Now, in this case, we're going to add an order by to what we just looked at. Okay, so we just looked at like sum over, average over, but we didn't have order by. Now we're going to add an order by. This is going to give us something different. So if you take a look at this, I've got sum over order by, which gives me a running total. Okay, now I'm getting a running total. If I just have order by here, it's going to give me a running total over the entire set of results. If I add a partition by, then that running total is going to start over for within that partition. So for customer 102, you can see how this, I should probably have ordered this to make it easier to see, but you can see how that value is getting larger. Let's take a look at that. So here I have a query where I'm doing exactly what I just did on that slide, where I have an overall running total that just keeps, let's see, order by customer ID. Oh, this one's ordered by sales order ID. So you're not going to see it exactly going up unless I change this outer order by. So let's do that. I'm just going to grab that part. So here you can see this overall running total going up. Now I'm going to get rid of that, and I'm going to just do this other one that I already had in there. And on the second one, I have a partition by, and you can see that it's going up for that customer, and then it starts over for the next customer. All right, this is all I'm going to talk about until I go back to the slides and talk about one more thing you've got to understand with these, called framing. But it is really easy to get a running total or a moving average, that type of thing. You need to have a little bit more information, which I'll talk about now. Okay, framing. I feel like framing is the hardest thing to understand about window functions. It took me a long time to get it. Thanks to Itzik Ben-Gan for explaining it, because I had bought his book originally, and it took me like reading the chapter where he talked about this like 3 times before I really got it. I talked about a window, and a window has panes. We can also have this thing called a stained glass window that could have thousands of tiny little sections, maybe millions of tiny little sections. All right, so that's what framing is like. It's like a stained glass window. When I do my calculation, previously I did my calculation on the entire set of results or a partition, right? Like if I partition by customer ID, each row with customer ID only saw the rows for that customer ID. Or for stock, only that stock ID. So in this case, every row can actually have its own window to look at. And we define that by framing. Again, this I think is the most difficult thing, but luckily it's only going to come into play in a couple of situations. There are some terms to learn. What I suggest is, I'll show you how to get the slides later. Download the slides, and if you need to, print this page out and put it next to you where you can go back and refer to it. We have a term called rows, which is a positional operator. It's going to define that frame. We also have this thing called range. Range is a logical operator. So remember when I talked about rows and dense rank, row number and dense rank earlier. It's the same kind of idea. Range looks at things logically. If you don't specify the frame, and I just gave you an example where I didn't specify the frame to get that running total, you will get the frame using range. That's the default. It also performs worse than rows. It always performs worse. So if you don't provide the frame, your performance will not be as good as it could be. There's also this term called unbounded preceding. If I look at my set of rows that I'm working on, unbounded preceding is the very first row. If they say unbounded following, that's the very last row. It could be the entire set of results, or if I'm using partition by, it's going to be that little section, okay? The first row and the last row of that partition. Current row is where I'm performing the calculation. So here's what a frame looks like. Rows between unbounded preceding and current row. That's a mouthful. That's a lot to say. There is a shortcut for this one. I don't typically use it because there's not shortcuts or there's not a shorter way to say it for all the others. So I typically write this entire thing out. So here's my set of results. If I'm using this frame and I'm doing my calculation on row 1, my frame that I should probably change that to frame, not partition, consists of row 1. When I'm on row 2, it's rows 1 and 2. So if I'm doing a running total, just think about that. If I'm doing a running total, I need both of these values. So as I go through the frame or go through the calculations, the frame just keeps growing. And every row has its own. Let me go back to that one. Every row has its own set of rows that is performing the calculation on. I can go the other way. I can start with unbounded following at the end and current row. So this will give me a reverse running total. So in this case, my frame is getting smaller as I go. I can also use this terminology to preceding and current row. Now, if you want to do this, you have to specify the frame. And the term range doesn't apply here. Another thing about range is that it's not fully implemented. There's other things that the specification talks about, but Microsoft hasn't implemented. Not only do you get worse performance, we don't even get all the functionality that it could have. So in this case, if I'm doing like a moving average, if I'm just on this first row, I'm just looking at this value and 2, 1 and 2, 3, 1, 2, 3. So current row, 2 preceding, and then it starts moving like this. Okay, so we've always got those 3 rows. So let's take a look at how to do this. All right, so here is a query, and I have specified this frame. I've got partition by, order by, rows between unbounded preceding and current row. It's going to give me a running total. Or I could say rows between current row and unbounded following, which gets me the reverse. I'm looking at that and I'm like, that doesn't even look right, but I think it is. Another way I could have gotten a reverse total is in my order by here, I could have added descending. That would also give it to me. So if I look at the first customer, here's the running total. Here's the reverse running total. All right. If I did not specify the frame, like in the previous demo, it still might work. So here it's still working. However, if you have a lot of rows here, you will take a terrible performance hit. There is it, and if you have 2019 Enterprise Edition, it kind of fixed that. But you still may not get the correct results. So here, I've left the frame out. If I leave the frame out, I get range between unbounded, preceding, and current row. Here I've specified the frame. I've picked some special customers. I'm using order date, which is not unique. Okay, so let me see if I can find the date. Here we go. My running total with the frame, you can see 794, 832, 861. But in this one here, 794, and it just does 861 here. That's because when it's looking at this, it says, hey, these are the same. When I'm in range is looking at it logically. So logically, it says these are the same. So I'm not really getting the running total that I expect. Okay, where rows just looks at the position, and that's what I want here. One way to solve this, if you don't have enough data to cause the performance hit, is to make sure that this is a unique column. I'm just using a non-unique one just to show you what can happen. So if I used the old method, this is one of the old ways to do it, where I'm using a correlated subquery and I'm joining the outer customer to the inner customer and using this less than or equal to. I will get the same kind of problem. Same thing happens if I use the old method. It also does not perform well. I can also, as I mentioned, use that moving average. So here, let's start with this part. I have the order year and month and the amount of sales. So what if I want a moving average? In the outer query, I'm using average sales over order by the order year and month, rows between two preceding and current row. So I want a moving average. Notice these first two, I'm only looking at 2 months, but then it starts giving me the average that I'm really looking for. So it might be that you want to even add this to a common table expression, and then in an outer query, eliminate the first two, since those are not giving you 3 months that you're looking for. All right, any additional questions at this point?
No questions, but I have one comment, and it's to those who doesn't have English as their first language. The word preceding doesn't follow the spelling rules of the English language, because it would typically be P-R-E-C-E-E-D-I-N-G. So that's a mistake that I do, and I've seen so many do it. They give me the code and say, why isn't this working? Because you misspelled the word preceding. So
yeah, so you can see that it's not giving me any red squiggly, but it didn't light up.
Yeah.
So make sure it lights up. I think it's funny when you said the term rules of spelling English, because there are no rules. It's just terrible. English is terrible. And somebody like me, who my brain operates more on logic than memorization. But in English, spelling is all memorization, and I have never been good at spelling. Which is, now that I'm editor at Redgate, I'm an editor. So editors should be good at spelling. So luckily, I have tools to help me with that. And you know, when I am editing, it's mostly technical reviews, making sure that the article is technically correct, and then I used other tools to help me. But yeah, so it is very strange that they did that. Great comment. All right, I'm going to get back to the slides then. We have more to talk about. Offset functions. You can see what's behind you. Lag. I thought, why do I have this funny image here? Oh, I'm looking at what came before. I might have taken that photo maybe in Utah or Arizona, maybe. Lead, first value and last value. I have this joke I always tell. Some people have a favorite movie. Some people have a favorite television show. Some people have a favorite music band. I have a favorite function, and it's called lag. So that's my very favorite. Lag and lead can solve so many problems for you if you have situations where you're doing self-joining to get rows from different, to get a value from a different row. In this case, an order by is required, no frame, so we don't have to worry about that. Well, we do have frame with first value and last value. So first value will get you the very first row of the partition. Last value is the very last row of the partition. So this is what lag and lead look like. Oops, go back to that. So I have the same data. I have this total amount. And if I look at the next row, notice that lag pulls this value forward. I thought I had some animation here, but I guess I do not. And lead pulls the following row forward. So you can see how that is pulled forward. And this one, 750, is pulled back. You see the 30 pulled back. So depending on what you want to do, I have to have it ordered. Again, you can use partition if you want. And this is actually how I solved that stock problem that I talked about in the very beginning. So this should make more sense now. When I was working with the stock, I needed the close value from the previous day. Okay. I can also use partition by. So in this case, I've got customer 102. You can see that I have the total amount. I'm pulling that forward for each row. Okay. I've got these nulls here because I can't go back any further than order 1. So when I'm here, when I'm on this order right here, I'm going to look backwards and grab that value. Probably easier to explain in the demos. So first value is the very first value in the partition or window. Last value is the very last one. First value and last value requires the frame. If I don't specify, it's going to be unbounded preceding and current row. So if I need last value, you actually have to specify the frame, or last value won't work. So here I've got partition by. So if I'm looking at customer 102, the very first value is 1050. So I've got 1050, 1050, 1050, 1050. The very last value for this customer is 296. So here we've got 296, 296, 296. I don't really think that first value and last value are used nearly as often as lag and lead. So I think for today, if you can understand how lag and lead work, I think that will be very helpful to you. Maybe put first value and last value aside until you get used to working with some of the other functions. So let's take a look at how lag and lead work. Remember the very first demo I showed you, the stock history table. All right, it's almost 700,000 rows. Here's how I solved that problem. This is the query I showed you at the beginning. However, at that point, you may not have understood what we're working with. So I've got lag, the column or expression that I need to pull from the previous row over. In this case, I'm partitioning by the ticker symbol. I don't want to compare different symbols. Order by the trade date. And here I'm using that in a calculation to get the price change. There's also an open price in this data, but the open price and the previous day's close price are not always the same because sometimes things happen overnight that can change the opening, that can change the price from one, before the next day. So here I've got ticker symbol Z1, close price 88.78. I can't look at yesterday because this is as far back as the data goes. But when I look at the next day, I see this value is pulled forward and I get a price change. I can subtract that 48 cents and on and on and on. One thing I will tell you is that lag works very efficiently. If you tried to do this another way, any other method you choose will not work as well as lag. And I actually had an article, I might be able to pull that up, where I have a whole article comparing lag to all the other methods. And I couldn't believe how many ways I could compare, I could get the same results. So that's the article. If you just go out on Simple Talk and look for it, just so many different ways that I could get the same results, but none of them, here's all the different methods that I chose. None of them worked as well as lag. So that, in case you're interested in that, and I can possibly, if I can find the chat, I don't know if I can find it. But you can just go out to Simple Talk and find that article. It was just, it's on the main page there. You scroll down.
And I think if you haven't already been to Simple Talk, it's a wonderful place to go if you like SQL Server.
Thank you. I'm the editor. It's been a dream job for me, really. I love it. Redgate's a wonderful company, and Simple Talk is all about knowledge for the community. We're not we might mention one of our products once in a while, but that's not really what it's about. Okay, so there are some other options with lag and lead. You can provide value. If I want to go back more than one row, I can do that. If I want to provide a default value instead of null, I can do that. So like in this case, I just have a 0 there instead of null. I can go back. If I want to go forward in the data, I have to use lead, because the first thing that I tried to do was break it by putting a negative number there. I'm like, what if I want to use a negative number? I love breaking things because that's how you learn. I can't do that. Can't be a negative number. So that was like the first thing I tried. Here's lead, where I'm going. Let's see. If I'm looking at this row, I've got 2. I want to go 2 forward, so I'm pulling this one 2 days ahead. typically folks are, it seems like lag is the most commonly used. Am I out of time already?
Yes, I forgot about the time too. Sorry.
So there's more. This is really a session that needs to be given over probably an hour and 15. So I don't know if you want me to keep going or just stop. I could just go through the slides really quick and just tell you some of the other things that we have these statistical functions.
For me, I don't have any appointments for the rest of the day, so
Okay.
if it's up to me, you can go ahead if you have the time.
Okay, yeah, I've got the time. Let me just go ahead and then, especially since there's a recording, anybody wants to drop off, they can. So they have 4 more functions that were part of 2012. Also, these performance is not as great with these until 2019 Enterprise Edition. The problem I have with these is I have problems pronouncing them, and so because they sound like some bad words, some of them. So I tend to like say what they're about. So percent rank is okay. Cumulative distribution, percentile discrete, percentile continuous. So that's what I call them. And if you think about basically lining some values up and figuring out where they rank. So it's very similar to the ranking function that I showed you early in the session. However, it gives you a percentile instead. And percent rank and cumulative distribution work a little bit differently. Notice that if I have this data lined up, percent rank starts at 0, where cumulative distribution starts at a value, and they both end at 1. So the values are going to be a little bit different. This one says this row ranks higher than other rows. This one ranks higher than 0 rows. This one says this one ranks at 11%. Okay, so I'm not sure when you would use one over the other, but that's, you know, if you're really into statistics, data science, maybe you would probably know when you'd want to use one or the other. There's also some functions that go the opposite way, and they also have this other thing we haven't seen before called within group. And with these functions, given a position, so basically these give you the position in a percent value. With this one, given the position, it will tell you which value corresponds. So if I want to do median, I could do 0.5. However, percentile, now let's make sure I get them correct. Percentile continuous gives you the actual median in this case. It does a calculation, excuse me. It calculates if you don't have an odd number of values, it'll interpolate where a percentile discrete will grab one of the actual values. Now, let me show you an example. So I have a table of this is the average high temperature in St. Louis, which is the area that I live in. And luckily, I remembered to use my C temperatures instead of my Fahrenheit temperatures that I'm used to. So when I look at this data, I can see that January is the coldest month and July is the hottest month. Here's the rank function that I showed you back with the 2005 functionality. So January is colder than 0 months. It's the coldest, but it's at position 8. I guess I've got this multiplied by 100. It's at position 8%. Okay, so it's at that percent. July is the hottest month. It's hotter than 100% of the other months, and it's at position 100% as well. So that's how that looks. I can go the other way. I can put other values in here, but if I want median, it's got to be 0.5. I can go the other direction and say, what's the median high temperature over all the months in the St. Louis area? So the median is 20. Because if I look at these 2 months here, they're in the middle of my data, but I do not have, I mean, if I had an odd number of months, and I just read a short story that had a different number of months than we expected. There were some months missing. Actually, I listened to it. It was a LeVar Burton Reads podcast where he read a story. But anyway, what happens with percentile continuous is it interpolates between those two and came up with 20. Percentile discrete grabbed this one. So they're slightly different. Questions about that? I have actually used this when I was trying to work on figuring out something with, I had pulled perfmon data for some hard drive, for some drive values, like, I'm even forgetting what I was looking at, but I wanted to find where the 90th percentile was. How did this drive perform 90% of the time? And I used one of these. I don't remember which one to figure that out.
I worked with Statistics Sweden for quite a while doing,
okay.
they're doing census data, so population forecasts and all things statistics. And the way they used to do all these calculations was to pull out the data from SQL Server into SAS and run the calculations in there. So when we upgraded to SQL Server 2012 and just showed the number crunchers about these functions, they were like ecstatic because things were moving so much faster because they didn't have to pull all the data into another tool.
That's awesome. It's actually possible to do these calculations pre-2012 as well. And I have a book. In my book, I actually show how to do that. Just because it's really complicated to do, but it is possible. So yeah, that's a really great example. So someone's using these. I just haven't worked with enough things with statistics to actually have used them. So cool that they are used. There are a lot of resources out there. Eventually, even though I learned a lot from ITSEC, I eventually wrote my own book. At first, when someone said you should write a book on this, I was like, I cannot do that. ITSEC wrote a book on this. But then I found that, yes, I explain things differently than he does. I have different examples, so I wrote my own book. And so I've written 2. This is the 2nd edition. And he's also written 2 editions. So either one of us, I recommend my book. I recommend ITSEC's book, either one that you would like to buy. If you want to really learn more about these. I created a Pluralsight course on it. That course, it seems like it was maybe around 6 or 7 years ago. I've learned a lot since then. The course is still valid, but I feel like I've learned a lot more since then. my own poor blog that since I work at Redgate and so much of my job is editing articles or writing articles, I barely look at my own blog, but there are some articles out there that I had written. I've written a lot on Simple Talk, and also other authors have written on articles about that. You'll see other recordings from me out there about these topics, because I have, at this point, really 3 sessions about window functions that I can do. So you'll see those out there. And also, if you would like to download the slides and code today, you can find all of that out on GitHub. So if you want to screenshot that really quickly, then you can find the slides and code from today. So that's everything I've got. And I really, really appreciate you letting me talk about my favorite topic, T-SQL window functions. And that's all for me today. So any additional questions?
There were some about where can we find the resources and so on. So I typed in the link to the GitHub in the chat window. So
Thank you.
And I think Vilnius sums it up pretty well, saying fabulous presentation, and I really, really agree. It was perfect way to spend my Friday lunch.
Fantastic. Yeah, this has just been, well, beginning T-SQL is also near and dear to my heart, but this topic as well. And I just love talking about it. I'm just waiting for Microsoft to add more. Add more. And I know Itzik is as well, because he actually knows what else is possible. I care about what I can do today, but even in his book, he has examples of, if they actually implement, we could do this other thing. And so I'm looking forward to that day when there's more. So I hope everybody has a great rest of their day, and I look forward to speaking at this again in a few months.
I hope you will. I'm pretty sure I will, if you want to. Sure. I was at a presentation with Itzik on Past Summit 2019. Back in the days when we could meet in person.
Yes.
And he had a presentation about things I wish we had in T-SQL.
Oh yeah, yeah.
And it was all things from the SQL standard that is not implemented in T-SQL, and it's some. I didn't know I wanted it, but when I saw his examples, it's like, yeah, I want all of this now.
Right. And if you do not have like the thumb drive or flash drive that had those sessions, you can go back to YouTube, just look for Past TV. All of those sessions are available on Past TV if you want to take a look at that.
Yeah, so. It is the YouTube channel with by far most content about SQL Server. I think SQL Bits has a fair amount of videos as well. So, and really there is so much out there. I enjoy watching a live session, but there is so much out there to learn from. And it's a really lovely community in that way, because you have people who so many people spend time to prepare sessions and give presentations without getting paid a nickel for it, and it's something that it doesn't exist if you look into the IBM DB2 community, for example. No one would dream about coming to a conference and speak without getting paid for it. So
yeah, that's a controversial topic, whether you should be paid or not. It's nice if you can get your travel arrangements paid if you have to actually travel. But so there are other things besides money that are benefits to speaking. So many things. And so once you start speaking, you start learning more. You you suddenly, people know you. Suddenly There's more job opportunities, maybe
Absolutely.
consulting opportunities. Speaking has so many benefits that you can't just think about money.
Yeah, and I think at least this is true for me. I would not run my own company and I would not be a consultant if it wasn't for the SQL Saturdays and user groups that I started speaking on. Because I kind of realized that I know a lot of things that not everyone else knows. Maybe I'm worth more than I thought. So it gives a really good confidence boost to do public speaking, I think.
Yeah, I really enjoy it. And they say it's very scary thing to do, but once you get used to it and get some confidence, it becomes very fun, especially in person, but we'll get back to that.
I hope so.
Yeah.
Yeah, I got the announcement that the Data Saturday in Stockholm is happening in person, and it's going to be in May, so it's a long time to it, but I really look forward to it. So I hope everyone in here gets there. So.
We'll see. All right. Well, I'm going to start my work day, I guess.
And I started. It's been 2 weeks now. I don't have any client work on Fridays, so I can do things like this. I can write blogs and I can record videos and just do the things I want to do with my time that I don't have the time for in the other days. And I don't want to spend the weekend doing it because I want to spend the weekends with my kids. So I decided I can live on the money I earn Monday to Thursday, and then I can do whatever I want on Fridays. So.
When I had my own consulting business for 3 or 4 years before I joined Redgate, I did the same thing. I did not what I'm going to call work on Fridays that entire time, and it was wonderful. So I agree. Yeah. I agree. It's just you can control your own work schedule like that.
Yeah. And like you said, money is not everything, and of course I need to get enough money to pay for my car and my house and put food on the table, but I don't have any expensive needs. So
very good. All right.
So good luck with your workday, and for most of the attendees, I think it's almost time to sum up the Friday and go to the pub or something. Thank you so much for coming, Kathi.
Thanks. Talk to you soon.
Yep, I will. Bye.